Hi, my name is Massyel Martinez. I'm going to present my project titled Expanding the Epigenetics Relevant Chemical Space, High Identification of DNA Methyltransferase 1 Activators. Um, oh. As a brief introduction, DNA methyltransferases are responsible for the regulated DNA methylation process. There are 5 types of DMTs. In this project, we only focus on DMT1 because of its importance in the maintenance methylation. And these enzymes have 2 main domains. The regulatory domain at the N-terminal and the catalytic domain at the C-terminal. The methylation is important in the gene translation because it regulates. When the methylation is downregulated, there is hypomethylation, and this could cause some diseases like some types of cancer, and this may also cause genomic instability. The main objective of this project is to identify compounds with the potential to enhance the catalytic activity of the DNA methyltransferase 1 enzyme, employing chemical libraries and computational tools. And the general methodology for this project is as follows. As a step 1, we search for previous published activators of DMTs and DMT1. Then we choose the chemical libraries to use in the search of new potential activators. As a step 3, we applied ligand-based methods with their respective enzyme activity test. And as a step 4 is currently ongoing, we will apply the structure-based methods. Well, the molecules at the right were used as queries we obtained from the thesis of Martinez and the article published by Rodriguez Mejia. The similarity test based on fingerprints were conducted using these molecules, employing Massyel and ECFP6 fingerprints and Tanimoto coefficient. The criteria for selecting the molecules was Massyel's value greater or equal to 0.8 and ECFP6 greater or equal to 0.5. Then Bemis and Murco scaffolds were calculated. The result was that the majority of these molecules share the same scaffold except for 2, this and this. And furthermore, a pharmacophore model was generated indicating the presence of 6 hydrophobic groups, 2 acceptor groups, and 1 of them is a donor. As a result of the virtual screening, we selected 9 molecules and conducted enzymatic activity assays. 6 of these molecules were activators. On the right, 3 of the most active ones are presented. These molecules have a similarity value with Massyel's ranging from 0.9 to 1, and with ECFP6 from 0.7 to 8. And in contrast, the molecules that were inactive, despite having values between 0.8 and 0.9 with Massyel's, exhibited very low values with ECFP6 ranging from 0.16 to 0.20. And also these molecules share scaffolds with their queries. And not all of them exhibit all the pharmacophoric characteristics. In fact, the most potent molecule that is this lack 2 hydrophobic points. And as conclusions, out of the 9 molecules selected through fingerprint-based similarity, 6 activate the TMT1 enzyme. The similarity values most pertinent to the molecule's activity were those based on ECFP6 fingerprints. And notably, the most activating molecules do not possess all the pharmacophoric points, and the hit molecules share scaffolds with queries. Finally, this work is made possible thanks of CONACYT, PAPIT project, and the FACIN work. Thank you for your attention.
Thank you, Massyel. We have one question from Dmitry Shulga. What is the mechanism of MT enzyme activation? It's interesting to understand.
The mechanism of activation have several steps because TMT1 interact with a lot of other proteins like PCNA, the histone 3, but the principal mechanism is that the domain RFTS dissociate from the catalytic domain, so the DNA can allow to the methylation.
Thank you. One question from Vladimir Paroykov. Do you think 243 plus minus 66 is appropriate expression if the standard errors is in the numbers before the decimal point? Maybe you look in the chat. Any question?
Oh, well, we only do two replicas, and we should do more to obtain more statistical values.
Okay. We have another one question from Dmitry Shulga. Should the compounds be similar to some, or the activators bind to the other sites?
Actually, we don't know because we already don't did the structure-based methods, but we think that the activators bind to another side of where some.
Okay, thank you.